All right, today's video lab is the reaction rate lab, where we will look at the effect of several variables on how fast or slow a chemical reaction goes. And from the notes, you should know the four variables that affect reaction rate. So the first section is concentration. So it says place equal amounts of different concentrations of acid in test tubes. So there they are pre-measured. And then it says to add the same size lump into the test tubes. And then you can see fairly graphically that this one is reacting much faster than this one. And you can tell the concentration. Now we could time this and see how long it would take, and it would take this one significantly less time to fully dissolve. Pause. The next section is the effect of temperature on reaction rate. So I have a hot water bath with the same concentration of acid as this one in the cold water bath. And then we do the same thing. We simultaneously drop antacid tablets, one into the cold and one into the hot, and holy smokes. You can tell this one is fizzing really slowly and this one is going great guns. Holy cow. Gee, I wonder what the effect of temperature is on reaction rate. Pause. Now, I thought we could have a little visual fun. These are glow sticks. One has been soaking in the hot water bath, the other in the cold water bath. I'll put them behind my back, and then I'll crack them, and then you tell me which one is which.
You want the lights? Oh.
Gee, I wonder which one's which. All right, pause. All right, the next section is particle size. So I have a large effervescent tablet, and then medium-sized chunks, and then powder. And I'm going to put them into 3 test tubes somewhat simultaneously. Large, medium, and if I can do this without spilling. Look at the small chunks, and then the powder. I'm going to spill. Uh-oh. The powder reacted so fast. Whoa! It didn't. It got stuck at the top, and it's overflowing. So, pretty graphically, you could tell which one went the fastest. Pretty fun. Pause. All right, this last section deals with the effect of a catalyst on reaction rate. So what I have here is hydrogen peroxide, and it spontaneously decomposes. We could sit here and watch for hours and hours and hours and hours, and we wouldn't be able to see it decompose. But it is decomposing. Trust me. Very slowly though. So if I take a splint and light it and lower it in there, there's no effective change because the decomposition, the production of oxygen is so slow that it's not visible, not effective. So if I add a catalyst, and then you see the fizzing at the top, which indicates there's bubbles being produced. So then we'll test what the bubbles are. From the decomposition of hydrogen peroxide, you should know what the bubbles are. Oh, rats. Science is messy. What should have happened? Shoulda, woulda, coulda. The oxygen should have flared up the stick. We'll see if we get that action going. There we go. There we go. Try it again. There we go. All right, oxygen. Cool. Awesome. All right, so I have one more demo just for the fun of it. I mean, just for the sheer learning experience. This one goes back to the effect of concentration. We know that wood burns in the presence of air because air has oxygen in it, but only 21% oxygen. Here I have a flask that theoretically is pure oxygen. I have a tank of oxygen here, and I pumped some into there. So hopefully this works. I didn't practice it, but here we go. I would say that's pretty cool. So, wood burns a lot more effectively in pure oxygen than in air. I'll answer the rest of the data analysis and conclusion questions for this video lab. Hope you enjoyed yourself. See ya.